Welcome everybody to my talk, Poke D, GNU Poke Beyond the CLI. I'm going to talk about CLIs today. The UI today. This talk is about UI, not CLI, not GUI, not TUI in a specific. It's about the UI. So what's a UI? According to the Wikipedia, the user interface is the space where interaction between humans and machine occur. And this is a very important thing. I think everybody should think about this problem because it's an important problem. We don't have to just use conventional things. We have to invent new things and make world a better place, you know. So this is out there, 8800, the first so-called personal computers. This is also a UI and it's a very nice UI because you could possibly manipulate the bits by your hands and see the bits by your naked eyes. It's very interesting, but we are not going to talk about this kind of UI. Here, my main claim is to we should design UIs to be automation friendly. That should be a core design decision, not just an afterthought that, okay, we have our program, which is, for example, GUI or TUI or anything, and we want to add some stuff like plugins. I don't like this approach. It's very restrictive. Good examples of this kind of UIs, which I want to talk about, is Oberon system, which is a system 1990. It's a very interesting. It's mainly for educational purposes, but it's very innovative and simple things. It has a very it's around the compiler. It has an Oberon programming language. It has a compiler for it, and the whole operating system and environment is interacting with the compiler. For example, all commands are function procedure calls, to be correct, to the procedures that are written in the Oberon system. And other nice example is Acme Editor, which is highly inspired by the Oberon system. It's written by Rob Pike for Plan 9 from Bell Labs operating system, which is highly interesting project, the OS and the UI, and Emacs Editor, of course. One point about the Acme Editor is that it's adapted good ideas from Oberon system to the Plan 9. And it's different because it's not like IDEs, modern IDEs, which you can implement everything inside the IDE. It's Acme is designed in a way that it interacts with the environment you already have. You can use all the stuff or the UI command line programs you already have in your machine and use them in your editor to enhance your life. And then comes Emacs Editor, which has very is good at automation. It has a basic editing things and a language around the text editing facilities, and you can build anything. These are good examples of systems that are designed to be automation friendly. And one note about question: if you have any question or notes, please interrupt me if you dare. And when you design your system in a way that is automation friendly, it has some consequences, like others can interact with your program more easily. If you look at and you are not forcing people to leave their favorite environments, terminal, editor, IDEs, web browser, you name it. And it's a good decision. If you look at current situation with web browser, you see what I mean. Every web system is forcing everybody to use web browsers, which are only two. We have only two options: Firefox or Chromium, and they're written in they're giant programs written in C++ programming language, which is also non-trivial to implement. So, for example, in you see in Plan 9 operating system, you don't have a good browser because it hasn't a C++ compiler, and nobody wants to do it because C++ compiler are hugely hard to implement. So it's a yes, it's a good for them, and but they can. That's not the problem of the user. That's the problem of the programmers. Web programmers are forcing. It's like if we force them to come to the terminal and look at the text the whole day, they will not like it. That's the same thing for other people, or IDEs and things like that. So back to the main topic, the poke. PokeD is a UI for poke, is a new UI for poke. And to understand it, we first have to understand the current UI, which is a CLI. And before that, we have to understand the poke project as a whole. So poke is composed of two components, a libpoke, the library, and the poke, the application, the CLI application, which is based on libpoke. And the libpoke has three main components. It has incremental compiler for the poke programming language. It has a poke virtual machine, which is a jitter-generated virtual machine. The compiler generates code obviously for this virtual machine, and the virtual machine interacts with IO space. What we call IO space is where bits are lying. You can interact with things. The actual data is in IO space. So when you write a program, the compiler generates PDM code, which can poke or peek, look at the data, read data, write data to the IO space. So that's the whole overview of the project. So current, if you attended yesterday to Jose talk, you would see that a lot of examples. It's a REPL program. You read, evaluate, print, loop program, which is popular. And in that environment, you can declare poke variables, units, types, functions, you name it. And user can compile and run statements and see the results. It's an interactive environment. And it provides some facilities more than poke programming language itself, like .commands, .help, .file, .mem, and so on. This is a demo. I think I don't need to open the poke application itself and do a live demo, but this slide is pretty readable. In the first here, I declared a variable of type integer and with value 1. Here we have a type T, which is a structure consisting of two fields, one 32-bit signed integer followed by 64-bit signed integer. And there is no padding or anything. And here we're defining a function f, which takes two arguments, x of type integer and y of type string, a null terminated sequence of data. And we're returning offset type of ulong and in bytes. So we are just adding the attributes, that's the size of those values. So you have to run all this stuff on a single line because it has limitations. That's the point of this stuff. So we are calling this function here with these two arguments, 10 and hello binary to submit string, and you get 20 in hexadecimal. And here I'm showing you the set command, which is not part of the poke programming language, is part of the tool poke, the CLI tool. You can change the output base of the virtual machine, actually. And you can call it again, and you see 32 bytes. And if you just enter the .set, you get all the options we have. And now let's look at inside the program, and let's ignore the command because they are not interesting to us. So in general, libpoke depends on two functions from the poke application depends on two functions, two main functions from libpoke to invoke the compiler. One is pk compile buffer. You give it a string with valid hopefully, a poke code, and it compiles and executes the code in the PVM. And the other one is PK compile statement, which, as name suggests, it cannot be any code. It should be a statement that if statements, while statements, expressions, and things like that. For example, you cannot declare variable. Declaration is not a statement. And how Pope decides that to choose which function is like this. If the input starts with var, unit, type, or func keyword, it will give whole line to the PK compile buffer. Otherwise, it give it to the PK compile statement. So, for example, here we have this line, all of one declaration, two statements, and it's valid. And the whole line will be given to the PK compile buffer C function because it starts with var. And but this second example, a plus equal 1, it will given to the PK compile statement because it's a statement, because the line is not starting with var, type, unit, or func. And as a consequence, this third example will be an error because we are putting two statements in a single line, which is invalid. You can just put one statement. So you see the limitation. You see everything which should in a single line. You cannot have two statements. Okay, let's dive into the code. So this is oversimplified pseudo code for poke program. The program, not the lipo. Imagine that we have a function called read command from terminal. It gives you a pointer, malloc allocated pointer to this imaginary structure. It fills this field with the first non-blank word, and this is the whole line. So, and a little bit of boilerplate like str equal check, which handles error handling of PK compile buffer and statement thing. And this macro check print will handle error and print the val, which is a PVM value, which is a poke value, you can say. So this is the main loop. The program waits for the user to enter a line, and you get the input. If it's null, you go to the inside the loop. So we compare the first one with var, unit, type, func. If one of those conditions are true, we will land up here, and we invoke the PK compile buffer function with the poke compiler. We give the whole line to it. Don't care about this, and we here, if exception at the level of poke level language, if some exception happens, this value will be filled for us, so we can check. Actually, the check macro should do that. And here, otherwise, we give it to the statement. The same thing, just we have one more extra argument, which is the val, and we free the input, and the loop will continue. Is there any question here, or is everything is clear? Sounds clear. So let's talk about limitations. So it's obviously not automation friendly. Somebody should sit down on the keyboard and write commands. It's limited to one read line input and one output. And you cannot embed the poke program in your program editor, ID, anything. It's not that much user friendly. I showed you some examples. For example, everything should be in a single line. You cannot have more than a statement. There is some workaround, like using the load keyword, the load language construct. Yes, we have a dot editor which opens the editor, but it's not very convenient. I don't know. And you are restricted to the terminal capabilities of terminal. So if you want to have a hex dump, you have to show it some way inside the terminal. Yes, we have like hyperlinks. We can enhance it, but so the solution, pokd. It's a daemon. I love daemons. You know, they are for people with no Unix or Linux background. It's a background process. It's a service in terms of other systems, and it listens on a Unix socket. It's like TCP socket, but it's a file in your file system, so it's kind of secure. Uh, it has notions of channels. We have a bunch of input channels instead of one. You see in the poke program, you have one input. You have more than one input channel. You can have more than one output channel. We will see why they are useful. And input to output channels are completely independent, and we had a daemon which listens on a socket, so clients can connect to it, and they should express a role, what want they do, what they're expecting from the pokd. They have to tell the pokd that they're interested in which channel. Is it an input channel or output channel? And the main interesting thing is that we can have more than one client simultaneously interacting with the pokd. This is a slide. I think it's a little small, but let me try to explain. This is the pokd program. You see here we have input channel on the left side, and we have output channels on the right. So the first one is special, already defined. Actually, the first one, whatever user writes to the channel number 1, the pokd will give it to the pk compile buffer. So it invokes that function, which is generally code. It can be any code, so we call it code input. And the other one is command input channel number 2, which whatever you give it to the right to a client, right to that channel, it will be compiled with the compile statement function. And we have a bunch of outputs. The first one is output, the terminal output, actually. So here you see there can be more than one output client listening to what's happening and do different things. The second one is what we call view. You can send hex dump to your viewer, and you can interact with your viewer. If you want to explore some data, you can use that thing. And the third one is interesting, the disassembler output channel. Poke doesn't have natively support for disassembly. Okay, you give it a bunch of bytes, it cannot decode it as disassembly. But we can, using if the poke can write to this channel, and if there is a disassembler on the channel, it will do the decoding. I have already will show you using Capstone library, but you can it can use radar, it can use objdump, anything. And tree view, we reserve the first 60 channels for ourselves, and user can use from 60 to 120 channels for their interactions with the poke. And again, if is there any question, you can write to the chat or ask me. If you are familiar with MQTT, you will see some similarities. In MQTT, we have topics, publishers, and subscribers. In pokd, we have channel, poklet, and poklet. We call the clients poklets. And that was suggested by Jose, which is very great at naming things. MQTT, it's just an acronym, but it's popular that it is message. It's message queue something, but it's not the true, because if you read the history exactly, it's a name related to some IBM machine or something like that. And it's a message broker. You have the MQTT. Publishers can publish something. Yes, thanks, Hamid. A message queuing telemetry transport. Yes. Uh, but you can read more about it. So MQTT is a broker, message broker. A publisher can connect to the MQTT and send, okay, I want to publish this stuff on topic that. It's a string. And you can have as many publishers, you can have many subscribers. Here we have similar. It's not the same because we are more limited. We have channels which are numbers. Topics are strings, and they are general. So when a publisher publishes something on a topic, all subscribers will receive it, and more than one publisher can publish it. So we have used this architecture in POKD, and poklets can put stuff on the channels and and the message will be dispatched to all of them. So let's look inside the POKD, the main loop, the way that we do for the poke application. So the same oversimplified pseudo code. It's not real, but it has the essence of what's going on inside this. So instead, here we have read from input channels, which are collecting message from all clients on a different thread, and it gives us input, which is some structure called channel. But it's not struct. Actually, in my current implementation is uint8. I think it will remain so for at least for a long time. But I just, for demonstration purposes, just to opaque things, I called it chat. And we have the data that the client wrote to the chat. And here we don't know which clients give us this. It's not important. We just do the compilation. So we have two accessor. We can define two accessor macros. Chan is input to define is it input or output, and chan num to give the actual number of the channel. The same logic here. We have a check macro which do the error handling, and check publish, which instead of printing it will publish to all clients that are listening to channel number 1, output channel. So this is the real loop. You see, we read from input channels, we increase the iteration. We want to somehow notify our clients that a new round of compilation starts. Be ready. What you get from this point on is for this new execution, and it's live because you can have print in your poke code. So we are checking for the channel number, channel. If it's input code from channel input code, we give it to the compiled buffer. Otherwise, if it's the command input, we give it to the check publish to the statement, and we publish the value to the author. And let's ignore other channels because it's not important. Now, let's have a visualize. For this slide, it's really improved my ASCII art skills, really. So we have POKD here. This is the status of the compiler, which is idle. We have a list for input clients, and we have a list for output clients. So we call it list, but it's the array. Doesn't matter. So a pokelet come in. It's poke in. It's right to the code channel number 1, the input channel number 1, which is code channel. First, it should tell the POKD the role. So it writes a byte with value 1. The most significant bit, the 8th bit, it's 0. So it means input. and the seven least significant bits are representing the channel number. So it's 1. And I reserve from 120 to 128 for future extension, but we are not doing. So when poke C, so the poke will poke the file descriptor of the first client to the list of input lists. So it will pull or wait for something to happen on this socket. And when the poke out program comes, this is subscribes to the channel output channel number 1, which is out channel, terminal output channel. So it happens to say it should do the same dance. Here, the most significant bit is 1. It means that it is an output channel number 1. So it will put the name in the out list. This is the client's number 1.fd. We will write everything on this socket, this file description. And then the user writes this statement, print hi, with a new line at the end. The poked will serialize or marshalize the thing. It adds prepend to the length of the command to the payload in Little Indian, because that's my favorite Indian. So it is 12 characters. So it is 0C in hexadecimal followed by 0, and the real payload. So all payloads are prefixed with the length, and we only have 2 bytes for it because it's more than enough. The pokedD get these inputs and the status. It start compiling and executing things. While it's processing, it generates some output, which is also prefixed with the length, and it will dispatch to the output poke out program. We can have more than poke out instances. It doesn't matter. All will get data. So we have 4 characters here because for simplicity, the pokedD tries to put a null character at the end of Python. It doesn't matter if you're sending binary data or text data. It will make sure that the last one is always 0. So here we have 4 characters, HI, new line, and 0. Poke out, get this message, and just prints the thing on the terminal. And you see here, it can idle, so the dance can go forever. So is there any question about this example? You can ask it now. So either nobody understand what I'm talking about, or everything.
Will any other output channel react?
No, we are dispatching according to the channel number.
Right, but so then the output channel number 1 will get anything that is written in the poke terminal.
Yes.
Okay.
Oh, let's see an implementation of this poke out program. I chose Python because it's denser language. You can put it on the slide, and if you can write something in Python, probably you can do it in any other languages, because if you do something in C or C++, maybe other programming languages cannot do it, but here I'm pretty sure that everybody can do it. So I'm in this example, I'm using Async Io module, which is a standard library module of Python. It uses asynchronous IO, which I like. And I'm using sys for flushing this to the output, you will see. So we have an async method main. If you don't know about async IO, you can ignore the async and await and imagine them, they are blocking. So we open a Unix socket to this socket address, and we write 81, means I'm interested in receiving data, output data, channel number 1. And we wait until the client writes this single byte to the user. And then we go to the while loop. Here, we exactly read 2 bytes and parse, decode them as little endian integers. So here, L is an integer now, is the length. So we read exactly L amounts of data. In this program, the poke out, the convention is that the first byte designates the kind of data we're receiving. So here you see the first byte I'm putting into the command, and the rest of data will go to the data. So if the CMD is 1, which means that we have the new iteration. You see, if you remember the iter n variable. So we expect that we will, after this point, the data is a 64-bit on-site integer in little endian order. So we get we decode that integer and save it to the iteration n, and we just print that, hey, this is a new iteration. For GUI, you could, for example, start a new window, for example, with a score that is distinguishable visually, that this is a new, this output is from a new invocation. If the command is 2, it means a normal output. Just append the data to the terminal here. So we as I told you, the last byte is always null terminated. So here we note the output string. So we exclude that and decode it as ASCII characters. And if it is non-empty, we will print without printing the new line, and we will flush because Unix will stay until the new line shows up in the standard output. So we have to force it to just show everything, because sometimes you insert, for example, a statement for A, for example, it will show the value of 1 and with no new lines. So or other kind of problems. So if you have to force the thing to flush out actually what it received. And the part that just run the coroutine asynchronously. So demo time. Okay. So do you see my terminal?
Yes.
Okay. So we have to start with, I'm using Tmux here, so I'm splitting here. I marked it. It means I'm here. You can see my cursor here, the black. So I'm first, we do the make. Okay, everything's good. Build poke B doesn't work. Okay, that's normal. It works. So now we don't care about the poke D anymore. We do care about the other poke. So here I'm going to, in this pane, I'm going to open the, for example, poke rep and write something hello, and you will see nothing happens. Don't worry about the stuff there. You see nothing because we don't have any output poklet. So we are here now on the right side. So here I'm going to poke. What was that? I changed the name, but it's not here. So you see, it's the iteration number and the message we wrote there. If you look closely, the cursor is at the end of the line. It means that there is no new line. For if we var a equals 1, we will see this is an empty, and you see the difference here. We don't see anything here because this, by default, this rep by default writes to the code channel. If we want to, if we want to do it in, consider this as a command, I decided to use semicolon as, in the beginning. If it starts with a semicolon, it's a command. So it's opposite of the poke application. So you see it's an A considered as a statement will give into the pk compile statement function call, and you see the result here. The good point is that you can have more than one simultaneous. I see. Let me change the here. See the A and the statement. You see the value. I can increase the thing. You see the number increases because it gets a new, and you see the numbers. I go back to this here, and I just write A, and I see, it's sharing things. I can have also more than one output thing, and the code is already in the poke D branch in the Git repo if you want to look at it. So here I'm going to again write statement A. You see, both of them are iteration number 10, and we give the thing. And let me show what I have to show to you. So we can have as many as, and one good thing is that we can have poke in, which print hello binary tools. New line, and I'm echoing this program. I'm piping the output to this program. It will send to the code. So you see that while the program is running, you can use them from command line. You can use the rep. You can use one more thing we'll show. So you can actually use, while you're working with poke rep, you can also do run your scripts. You want to do something to your data. So, and the nice thing that I like most is the fields. F, I think, yes. No more. Okay. This is a program. This is a fields file system in user space. So this is based on the example of path through of the official thing. So I'm opening here, you see. If you write to a file in the fuse directory, poked.txt, if anywhere in this new file system you edit a file with poked.txt, I already have something here. Yes. Let's take a copy. Poked.txt.alt. Okay. Is it readable, or I should do something, close something? Okay. Let me check. I'm curious. Okay. So here I'm in Vim editor. So I will say print value, literal value of A, and this is a print statement in poke. You can also put parentheses around it. So when I save it, here you see that I'm saving using the column W. It will give us an error because I'm using the wrong function. Okay, printf is the right function. So I'm writing, and it writes the thing here. So, for example, I'm inside my editor, and you can deal with poke inside from your environment, even browsers. Oh, Jose, your today is your lucky day because I couldn't make ready the WebSocket thing to actually edit, to interact with poke from inside browser. So it's not in the shape that I want to show. So,
well, I was looking forward to it.
yes. But sorry. And here I'm going to increase the variable and then print it. I write, and the number you see is 3. So let me try with a different editor, MG. So this time I save it as soon as the file is written in the disk. You will see the result is here. And you didn't lose the terminal thing too. And we have more than this. For example, let me go back to my Vim. You can interact, you can write in your poke code, which is interactive. You can redefine everything. You can redefine types, files, units, anything. So while you're developing a pickle, pickle is a module, is a poke types, functions that are domain specific. For example, elf pickle. For example, you're doing a pickle for PDF files or JPEG files or something, and you're developing this type p struct something law string, for example, as something like this, and you can just save and everything will run. So at this point, you want to test something. You put an exclamation mark at the beginning of the file, and okay, you want to know the, I don't know, for example, the size of t. I'm creating a value of type t, and I'm getting the size attributes. So no semicolon, no anything. I'm writing it, and I get the answer, which is 40 bits. And if you looking closely, this code here didn't run. It starts from the end of the file and looks for the, I don't know how to use Vim correctly. So it's my main editor, but I don't need fancy features. So this is you can continue interacting with both as usual. This is what I want to debate, to interact with. And then for example, you want to start a new section of coding, new section. And from this point down, you can still have, for example, maybe I have to be less boring. L equals 0 and S equals hello, something like that. And print, let's put a print previous section here. No, you don't have to write it. And printf the value in 3. Yes. And this is, when I write it down, you see, you will only, there's a problem. It seems there's bug here. Okay, let me remove the T. No, I think something crashed. So yes, I don't know what was the problem, but you see the result. And it didn't run this section of code. It's very convenient. You can add sections to your code while developing pickles and things like that. And at any time, your editor becomes your command line, like 1 + 1, you will see 2. And any question regarding this stuff? Definitely manifests. Yes, yes, yes. I'm looking forward to see Emacs. Matthias is writing something. So these are just simple examples, I mean non-graphical examples. I have some graphical interfaces for you too. But let's see what's Matthias is talking about. Okay, could be used for Jupyter Notebook. Yes, yes, it could be. That's the point. You can use it. You can interact. You just need a broker to at one end talks to the POKD, and on other end talks to the other protocol. Is Jupyter Notebook or other Emacs or anything. Yes, and so back to the UI here. So let me close this one and open Poke View, which is a Python program. So I'm using tiling window, so this is a new window you see here. And let me put it here. And okay, here. So we have imagined that we don't have the dot commands, unfortunately, here, but we can use. We're going to start a new section here. So let's open. Oh, I have something. Okay, demo 01 hello, and iOS are the only. I'm using this file as in read only mode. So I don't know how much time do I have. I don't remember when I started. So
don't worry about it. Use
okay.
as much time as you, because the next speaker is actually missing in action. So.
Oh. So I'm opening. I have it. Let me show you here the demo. I have an executable. You can see file demo 01. It's an ELF executable 64-bit. It is for ARM 64-bit architecture. So we are going to poke this, not poke, just peeking, looking at the thing. So I'm opening in and putting, recording the IO space handle. So then what can I do? Okay, I want to pump the let's start ELF and for example var file equals ELF ident at in this IO space at offset 0. So this is the syntax we use for we want to map on this IO space at this offset, and ELF ident is the first few bytes for the ELF file to actually recognize the ABI and things like that. So, and I want to view Okay, what's the problem? Elf ident. Why?
An underscore, maybe? It will.
Oh, yes. Yes. Thanks, Jose. Yes. You see, here I have the hex dump. You can do normal dump. Let me show you the normal dump. See in the output. In the output here, sorry for my windowing system here. This is a normal dump, which dump stuff on the terminal output. So, but here we have a view command which sends, oh, what happened? I opened a new file. I need a new section. So it's actually like, for example, from offset 10 bytes. I think I screwed up things. Okay, it's not offset. Oh, from, that's from. Yes. I managed to show stuff from offset 10, you see here. And one interesting thing, while I'm interacting with this UI, you see my terminal iteration goes up. It means I'm sending, something is happening. The viewer are sending code actually to the pokd. Here you see at the output, I'm running this poke function. Actually, I'm sending this text to the channel number 1 that please set the dot, the cursor from this point to this point. And it's a, you can see in the dots, for example, you see it's from nibble 72 to nibble 179. So we can use this stuff, for example, to view highlights. It highlights the part. And the good thing is that the viewer is absolutely stupid. It has no idea of hex dumps, offsets. It just texts. All the logic is inside the poke. So, and how I accomplished this, I just wrote a poke script, which I load at the beginning, and I define all these functions there. And you can have definitely more than one. Let me use here poke view. Okay. Here I have, for example, view. Let me, okay, you see both of them are receiving the same data. And if I change the dot, I can see the highlighting. So you can have a TUI in your terminal while you're doing your Emacs, for example, and you're doing also in your browser, and or there is no limitation. But this is not very useful to have multiple things. We need to, sometimes you have more than one IO space, and you want to, or we have one IO space, but we have different, we want to look at different offsets of the file, actually. So I have to extend, I couldn't make the time for this. I was making my slides. So it's very easy. Just somewhere I needed text input to tell me the topic somehow, the filter string. If the message from pokd starts with this ID, I will show it. You know, it's an interaction between poke and poke will send it to everybody, but the viewer decides it's no longer stupid. It has some notion of doing things. And there is also a viewer which I have to copy some code from. Oh, before that, I want to remove. I will show a tree viewer, but before that, I want to show you something more amazing or beautiful. I don't know. The disassembly poklet. So how it works, we through a predefined protocol, we tell the poklet, which we don't know. If we don't have a poklet, it will be discarded the message. It works like this. Hey poklet, if you please, this is a code of this architecture, for example, ARM AR64 or x86 32 or x86 64, and show me, decode this as a disassembly and show me the results. So here, this is an L file, right? I think we have, no. Okay. We have, we can find a file like ELF64 file. I showed you, this is a real AR64 executable. So I'm doing this, and var text, I'm get section by name. I'm interested in the text. I want to actually look at the code, so I need something to fit to my disassembly. So here, is everything clear here, or
Get the first element of the array.
yes, yes, I will do it. Oh, yes,
Yeah.
I was planned like this, but I forget. Yes, thanks, Jose. So this is the text section of the file. So we are going to, if I don't remember function name, let me, this as, yes, it is just this. And you see the function itself in Poke is this little, just this little. So this as, okay, I'm writing in the wrong file. Oh, it's not here. So
I'm a little bit confused. Did you
I am
restart
too.
the poke daemon?
I don't think so. It should not be like this. I don't know.
Okay.
No, it never acted like this. Let me see. File. There is no file. A. There is an A. You see, it's 9.
But
I think
the elf pickle was already loaded, right? Okay.
yes. I don't know. Maybe I did something wrong. And we are loading elf again. I think it's okay. Elf or here. I did some last minute changes. Maybe those are, no, we don't have here. It's elf, so we have this file and this file, this section. Just print, for example, print f the text unhandled. What's happening here, really? Get rid of this thing. Bash. Oh, it's a bug. I think it's a bug in Poke because an assertion failed. Let me.
Yes, that's a bug in Poke. Yes.
Yes. Fortunately, it wasn't my fault. Oh, I have this unfortunate power to crash Poke. I hope that it did not happen in my talk, but okay. Let me get. here, and the fuse poklet we have to on mount u fuse again, run the fuse thing. Yes, and we need a sync. Okay. Oh, we don't have, because I just removed the stuff. Yes. Sorry if this is getting a little out of hand because it's live. FD at this offset. So yes. And again, we have a problem. I triggered the same bug again. So let's try something else. I screwed up my, yes. Again.
Please make sure to report that.
Yes, I wrote it down.
Thanks.
Yes. So we know for sure that we have, let me SH offset. This is better. Oh, I have to. Oh. Yes. Here we have actually, there's a bug in printer. Yes, we will fix it. So what I'm going to do is, I no longer need this section, so I'm starting a new section. What I want to do is first, maybe directly disassembly. I would say that it is this architecture, text.sh, offset, byte. I want, for example, 24 bytes of FD at offset 0. I want disassembly this. I want to see that, oh, I have a disassembler. I have to fail. I swear I checked this code. Okay, let me start with the simple things. AR64. Because I'm stupid, I'm using first 0 offsets, that's the ELF thing. I have to say that. Let me make things look nicer. So this
And why do you
here,
have to specify the offset twice?
This is for the this is for the disassembler to show the address.
Oh, okay. Okay. Makes
And
sense.
this is text.sh offset. So yes, we have it. You see here is a knob followed by a. So you may say that I am making up things, and how could I know that this is a right thing? Yeah. And something is. I just. This is.
You can probably use text sh size in the array because it can be bounded by size.
Yes, but I just want to start a new obj dump to actually prove people that it is doing the right thing. So arch obj dump a text disassemble and less. Okay, I have to specify file. It's demo. You see here 640, and it looks similar. Move Z. Okay. So we don't. This is written. This disassembly is written in using libcapstone. You could imagine using any other kind of like the obj dump. You can have a small script, bash script to call obj dump, or you can use more advanced things to disassembly your code. So, and let me check if there is a question or not. So, no. Nobody has a question so far? No. So let me do something weird, and I wanted to do this live, but no, I will not, because there is my code pokex. It's a demo, not live font. Yes, let's build an UI, PK Here you see it has 3 buttons. Declare A. Oh, I already declared A. Anyway, declared A. You see, and I want to check the value of A. You see here, it's 0. You see, and I'm incremented. You see the 1, 2, 3, 4, 5, and I can decrement. Let's see how this works. This is like this. Here in Python, again, because of simplicity, I'm using pkinter because no dependency is a good thing. We're opening a socket to the to this Unix socket, actually, to this address, and sending the code 1, which is I'm interested in input channel number 1, which is code channel, and the other is suck cmd, which is channel number 2. So we have a very simple function here, send data. It just loops and in the blocking mode and send all data. We have this notion of poke send command. No, this function actually, it put the lengths a little in the end encoded lengths before the data, and just send the data, and to different sockets. Here, when we send poke send, it uses suck cmd, and poke send code is soak on the socket code. So here I want to just show my GUI skills. So this is the root. I put 3 buttons, see when declare A, increment, decrement, CMD1, CMD2. And you see here, CMD1 is sending the code var A equals 0. Send code is this, send this code and send this command. It will show it to us. And the same thing here. I just put 3 buttons here and just pack it and run. And this is stupid, of course, because I'm doing networking and I/O inside the main loop. But for this little demo, I think, and you see the power. You can make GUIs as powerful as you want, but very simple and very composable way. And there is another. There is a tree view, but to be honest, I don't remember how to use it. Let me try. Okay. And we also need a. I hope everybody follows what I'm doing. Poke view. I'm opening a view, and I have a tree viewer, and I'm going to here copy some code. View. So we have some data here, and I didn't test it with alpha. I want to do header. Is this right, Jose?
Yeah. Yes. ELF64 HDR. Yes, that's the name of the type. Yeah.
H at 0. So we have this thing, and then we are going to tree view structures H, and we have to give the type of H to the program. So you see here we have all the fields. It's not nested yet because we don't support nested types. because the type of should recursively go through all the elements and give us the whatever they want to. So here I can, for example, I can define anything, but here I'm just to show you how, and the value is the offset actually. It's not the value itself. These the nested types is a work in progress. It will be soon, okay, and we will have a real tree view very soon. So here you can see that it sends a command, but the command is highlight command. You see, please highlight this offset to this offset. For example, I can start from here. The first 16 bytes are elf ident. Then we have e-type, then e-machine. You see, you can build either all your UIs inside one big programs, or in Emacs, for example, we can have all of this stuff merged in one place, or you can have different programs which are interacting with each other. It is a little hard to, it's a lot of hard for demoing, but I wanted to show that these are small, very little programs that actually work. For example, I can show you the code of this viewer, for example, just to prove it's working. It's Python, and it's just 159 lines of code with white space and whatever. It works like the output. The first one, if it's the one, it means clear the screen. If it's number 2, it means append the string you get, and we have a highlight command. We can have as many as commands we want, and if you look at the PK poke deep, this is whole machinery that enables this dance to happen. 288 files, for example, and we have a disassembler. Here I'm using an interesting technique. I'm opening a memory IO space. Things that start with star and end with star are memory. So I'm having this data structure string, which is null terminated thing. I have a little endian uint64, which is an offset of type byte. So it's my address. And the code you want to disassemble. So I make this structure, initialize it actually, and then assign it to this file descriptor and sending to the channel 3. Channel 3 is the place that this assembler is waiting for data. So this amount of bytes, this array is bounded by size. You see it's useful. And at this FD at offset 0, and then close this IO space. And the tree offset is something like this. This is very short. This is our protocol. We don't have any external specification. This struct is the protocol. We are the first one is append, and then offset size, number of fields, name of field, type of field, these normal things. And we do the same thing. Fill the structure and put it in the IO space. We are converting to bytes actually, and that at that offset, we will send it to the channel number 4, which is for tree viewer. I think it's enough because I will ask people if they want to show something, because you may get bored. Maybe you are already bored. I don't know.
I have a question.
Okay.
This code, I mean, everything is actually executed in the daemon, right? I mean,
yes, all the logic is in the daemon. Yes.
So I think that seems to me that the idea here is to keep the poklets as stupid as possible, and and have as much as possible written in poke, right, and executed in the daemon.
That's
okay.
exactly the thing. We are moving all the logic to the poke deep, because writing poke is easy, and each poklets needs some kind of support code. You see, for example, when a viewer starts, it should define some view functions and things like that. When it starts, it can send the code to the pokd and says, okay, this is my support code, and after this point, the user can use the stuff. Or with my approach, I put everything in a file in the pokd itself. So it's very flexible. You know, we can have as many as we can. I will write all of the things. Actually, the only missing parts are these three. WebSocket works, but not very well. You know, the plot when you want to visualize your data. You know, you need something like histograms and things like that. These are useful when you are exploring data. And poke ID, I wanted to show that you don't have to live with this separated process. You can put everything, for example, in a GTK or Qt program, just to show it that it's possible. Or we will see your Emacs poke.
For sure.
Yes. And you can put all of these poklets in a single Emacs pokelet, something like that. Yes.
Okay, so I guess that we need, for sure we need some sort of namespace here, right? I mean, we need some sort of prefix.
Yes.
Like pillet or something for poklet. I don't know.
Mm-hmm. We can figure it out, yes.
Yeah, and also we need a list of standard calls, right? Like VU, like TreeView, like.
You see, maybe I have to show people. I'm for dump, maybe not. For dump, for view, I'm using this. If you look closely, the dump and view are showing essentially the same thing, because I'm using the same code. There are a lot of opportunities for shaving code between poke and pokd.
Yeah. Okay. Okay. Yes. Also, we have to talk about where to put what in the package tier and everything. Yeah.
Yes. I hope sorry for the crashes and things like that. It happens. Sorry, I changed my code at the last minute. I shouldn't do that. But okay, I think you get the idea. And just a few, if I have time, just to conclude my talk. We have so many years ago, computers started as a tool for automation. You know, there were people, but they started using we need machines for that. So you give the recipe and the instruction, and computer will execute them. So that was the idea when we have computers. But nowadays we don't use computers only for automation. We have a lot of other stuff, like creating PDF, watching videos, surfing the web, writing programs, debugging, reversing data formats of programs, exploring it like scientific research. You have a lot of data, you want to understand it, and you don't know. You have to explore it. You have to deal with it. You have to do it interactively. And the same thing for programs performance. For example, when you're doing, I did something for Jitter. It was nice. You could track the memory allocation. It was GDB based things. For example, then you visualize how much it's using memory. There are a lot of like this tools, flame graphs and things like that. These kind of things, you exploring data. And CAD or editing and photos, and these are not, if you look at them at the first sight, these are not automation friendly. But I will say that if you see patterns, that's a sign for automation. You will see patterns everywhere. So there is some chance for automation. You don't have to do like 100% automation. You can, as we will see, for example, people may say, okay, we have some creative things like writing code or editing images or videos. These are non-repetitive, but I think there are already automation. If you look at the Photoshop, they have a notion of action. It's something they called it programming language with no textual representation. Actually, Sean Parent, one of the grand engineers, said so. So the user do something, and the Photoshop understands it and replay it. For example, you want to resize your images. You want to apply some kind of filters. So you see, even people in graphics use automation. So it's really important to put automation as a forefront, as the first thing you want to do. Please, so my final word, please don't hide your model behind the GUI, TOIs browsers. Make them available as standalone models, like the small AD definition, the data, operations on data, and it is observable, it is controllable. You can look at it, you can change stuff. So please make your programs like this. Don't just, okay, you have to use this GUI. No. Please, this is the point that web browser fails. That's a bad thing. We want to be able respect everybody. Sometimes you want to do some repetitive filling a form to, I don't know, pay your bills, but you want to have a script for that. It's not fun to all this amount. So please, all of people should think about this. Respect your users. Don't hide your model behind the GUI thing. And thank you for your interest. And if there is any question, I will ask. And thank you, people, for doing something nice things. Thanks. Yes.